Welcome to Peak Performance. One of the new emerging issues faced by farmers in the world today is the unpredictable weather patterns brought upon by climate change. Whether farmers are a large-scale corporation or a family-owned farm in developing countries, these challenges are common to farmers around the world. It is said that in recent years, large-scale farms in developed countries have experienced a reduction of nearly 17% in their yearly crop yield due to irregular weather patterns. While these large-scale corporations are often subsidized by the government and have many resources like large data gathering facilities to adapt to these challenges, small-scale farms and farmers in developing countries do not have these luxuries. Instead, they'll often lose a large portion of their yearly harvest, leaving them nothing but empty-handed. Not only this, in these small countries around the world, a farm's impact is significant on the communities they serve, and so small changes in weather patterns can lead to a large-scale impact across their societies. Peak Performance is a data-driven, holistic solution to tackle the issues small-scale farmers are facing by creating a one-stop location where farmers can have access to all the same sophisticated data that large-scale farms and corporations have, allowing them to make informed decisions about the crops they grow and how they do so. As an integrated whole, Peak Performance combines environmental hardware sensors and software-driven agriculture-specific APIs to create a beautiful dashboard to give farmers the data they need in the most customized way possible. Let me show you what I mean. So on the dashboard here, we can click Get Started, and we're greeted by this page where we can select to draw a polygon. So for example, say that I am a farmer in South America. I can zoom in on this map here and find my plot of land on the map itself. So for example, let's say I zoom in here and I want to create a polygon to analyze. So the easiest thing that we can do is that we can click here and, for example, we can create a square on this map in order to analyze. However, what's unique about Peak Performance is that using this tool that created, we can create an infinitely customizable piece of land. So for example, if I want to zoom in further and I see that there's an irregular piece of shape of land here, I can go here and I can create my polygon as so in order to get the most detail out of this piece of land here. And then we now send this piece of land to the backend by pressing this button right here. And now this will be analyzed by our Go backend in order to get the most accurate and updated information regarding the environmental conditions here. Not only that, in the hardware sensors tab here, we have data provided by our array of hardware beacons that are providing real-time data based on what the sensor is seeing in the CO2 levels, the total volume of organic compounds, pressure, and temperature. So all this data here is updated in real time, and we have a graph showing the historical trend along with the current value that it is currently at.
Here's the hardware component of our project. This beacon is powered by an Arduino, which gathers data from carbon dioxide, air quality, pressure, and temperature sensors, and sends it through this USB cable to the computer. We were originally planning on achieving this using wireless communication. Unfortunately, our hardware didn't come in time. Anyways, on the computer, a Python script parses the data and uploads it to a Firebase cloud database. The front end then reads this data from the database in near real time and displays it in a series of beautiful graphs.
So after taking a look at the hardware, we can move on to the last part, which is the data analysis. In the data analysis tab, we have the information provided for the plot of land that we selected and create polygons from our Go backend. So we have things like the normal difference in vegetation index, which is an indicator of the vegetation in that area. We have things like UV index, temperature, pressure, wind patterns, cloud coverage, and as well on this graph we have historical data showing the data and trend over the past couple of days. So for example, if I look at the temperature graph here, I can zoom in on a couple of specific points to view the trend over those couple of days. I can zoom back out. I can save this graph as an SVG, PNG, or even a CSV file in order for the farmers to view later. And yeah, so overall, this was kind of a quick holistic view at Peak Performance. You can create a polygon here using the Select Polygon tool, and then you can send this data to the backend where we can analyze using the Go backend and our API calls. And then taking a look at the final kind of architecture of the entire project, this is what you're seeing here, the React frontend. This is the user entry, and all the data coming from the data analysis section is coming from the Golang backend. The hardware sensors are built on top of the Arduino platform. The information is parsed using Python and is sent to the Google Firebase. And then this is read in real time by the React frontend in the hardware sensors tab here, which is the information that we see here. And everything is combined into the kind of discrete package, and everything is seen through the web app through React.